Alright, so what we're going to be talking about today, it works off of what we learned last time. Last time we learned sequences, which is when you guys had a list of numbers separated by commas, and we learned two different types of sequences, the arithmetic and geometric. What do you have to do to create an arithmetic sequence? What operation are you using? Adding. You're adding something as you're going forward. What about for geometric? You're multiplying to create the sequence. What we're going to be learning about today are series. There are arithmetic and geometric series. What you're going to do is it's based on this, so you have to have a sequence first, but what you're doing is you're basically adding those numbers together, and so we use the word sum. So a series is the sum of the terms of whatever sequence you guys are working with. So you have to have the sequence first, you have to have that list of numbers, and then you're going to add them all together. That's what a series is. Okay? So we have some formulas for that as well. It's on your formula sheet underneath the A sub n formulas. You're going to see S sub n. S stands for sum. There are a couple different versions of the S sub n formula, but this is the one you are most interested in for the arithmetic. Right? So what things do you guys need to know in order to find the sum? You need to know n. You want to know how far you want to go out to the sequence, how many numbers you're supposed to be adding together. You need to know the first term and the last term. That's what all you need to do. You add the first and the last terms together, and you multiply that times n divided by 2, and that will give you all of the numbers added together. Okay, so it's a pretty straightforward formula here. So for example, we're going to find the sum. When you guys see the word sum, that's how you know you're using the S sub n formula. So look out for that word. Look for series or sum, and that's how you know you're going to be using the S sub n instead of the A sub n. So we're finding the sum of the first 10 terms of the arithmetic series, where A sub 1 is 6 and A sub 10 is 51. So I'm trying to find S sub 10. Right, so they want me to go out to the 10th term and then add all those together. So do I know what n is? It's 10, right? So they want us to go out to the 10th term and then add everything together. Do I know what the first term is? They straight up told us it was just 6. Do I know what the 10th term is, that last term I need to go out to? 51. So they basically just told us everything that we needed to use to plug into the formula. This is the most straightforward version. Sometimes you have to just look at the sequence like we'll see in the next one to find A sub 1 or A sub n. Alright, so this is going to be 5 times 57. This is 5, and add those together you get 57. So it's 5 times 57. 285. So if you were to take all those numbers and write them out and then add them together, you get 285. That's what this formula does for you. Alright, for this next one, we're trying to find S sub 12. So we're trying to add the first term, second term, third term, all the way up to the 12th term. We're adding those all together. So for S sub 12, do I know what n is? 12. I want the 12 terms, right? So 12 divided by 2. Do I know what the first term is? 2. Do I know what the 12th term is? I do not. So how do you think I'm supposed to plug that into the formula if I don't know it? No. Don't we have a formula for helping us to find A sub n?
We gotta dig it.
What have you done?
We gotta like go back.
You don't have to keep adding. We have, if you guys are missing something, we have the formula from last time where if the sequence is not complete up to where you need it to be, you can just really quickly use the A sub n formula to figure out that term that you don't know and then plug it in. Alright, so over here, if we're trying to find A sub what? What term do we not have? The A sub 12. We need the 12th term. So just really quickly look at your formula sheet. How do I find that for an arithmetic? 2 plus 11. What am I adding each time? 3. It's 11 inside the parentheses because you're supposed to do n minus 1, remember? So it's just 35. It's not that painful, right? You already know how to use that formula. So if you guys are missing one of the things, right? If you don't know what A sub 12 is, or A sub 1, or whatever you're looking for, just really quickly go back to the formula we learned last time, figure out that piece and plug it in. So it's going to be 6 times 37. 222. Alright. So notice, do you guys see how this has plus signs in between them? That's how they write a sum instead of commas when they're writing out a series. they write 2 plus 5 plus, they write all those numbers with pluses in between them instead of commas, and that's how you know it's a series. Alright. This one is really the most difficult of the ones you guys are going to run into. So if you know how to handle this one, you'll be in good shape. So this one says, find the sum of the terms in the following series. They have 6, 13, 20, 27, ... 97. What does that ... mean? There's terms in the middle there that we don't know, but ultimately it's going to end at 95. Okay? So this one has a different approach that we're going to use the same formula, but with a different approach. So, do I know what n is? Do I know how many numbers I'm adding? No, because that little ... took a bunch of them out. So n is what we don't know. Do I know a sub 1? Do I know a sub n? Yes. So what is it that I don't know? N. So we're going to go back to our formula that we learned last time to help us find n, and then we can piece it together. So again, if you're missing something, just go back to your formula from before. So what should go first in the formula? A sub n? Sorry, on the other side of the equal sign. Remember, a sub n is on the left side of the formula. And didn't we talked last time that a sub n represents the last term in your sequence. So if you have a finite sequence and it's clearly stopping here, this is going to represent your a sub n. So if you want to label it like that, you can. So we have 97 equals, do I have the first term? 6. Do I know what n is? No, so it's going to say a variable. Do I know what d is? What am I adding each time? 7. Okay, then how would I solve for n? You can do it that way. Or you can subtract the 6 and divide 7. Either way, you'll get the same answer. So you get 91 equals n minus 7 in parentheses. I don't know what that is. It's 91 divided by 7. 13. So 13 equals n minus 1. So what's n? 14. So I want s sub 14. I just found out that n was equal to 14, so I can start plugging that into my formula. Did I know what a sub 1 is? 6. Do I know what a sub n is? 97, your last term. And then you can just piece it together. Say again? 721. Right, so 3 different levels of how you guys will see these questions being asked. Again, if you're missing something that you needed, go back to the formula that we learned last time and solve it. Right, then we have a word problem here. We're building a wall with Legos. The first row is going to be 15 blocks, and then each consecutive row going up is 2 less than the one before it. I want to know how many Legos total does this person need to build a wall with 5 rows. So, what do you guys think about this? What's one number that I know already? The first row is 15. Do I know anything else? What's the next row? 2 less than that. So the next row would be 13. And then the row after that? 11. You guys see the pattern? I was going like this? So how could I use the formula that we just learned to approach this? Because we're trying to figure out how many total Legos does he need to build the entire wall. So isn't that a series? I'm taking the number of Legos on the first row, the second row, the third row, fourth row, fifth row, and I'm adding them all together to get the total, right? So how do I plug that into the formula that I just learned, S sub n? I'm trying to find S sub what? 5. Sorry, my S and my 5 look very similar. I'm trying to add the numbers for the 5 rows. Do I know what n is? Yeah, because I'm trying to go to the 5th row, so I know n is 5. I want 5 terms in the sequence. Do I know what the first row was? 15. Do I know what the last row is going to be? Well, we could keep going with this pattern that we had, right? This is the first row, second row, third row, subtract another 2. You see that? So I don't know why I wrote a comma there, it should be a plus. Right? Since it's not that many numbers, you can just use mental math, subtract 2 a bunch of times to get to that 5th row. And then you just have to add you can either add them separately like this or use the formula depending on what n is. So that'd be 55. So you need 55. So be on the lookout for these word problems and being able to tell whether it's an A sub n or an S sub n formula. We saw a word problem last lesson too, but it was A sub n because they were trying to pinpoint an exact term, like if something was falling, what would it be after 10 seconds, right? It's just asking for that one term. You need to read into the question to see if they want you to add all of them together, and so it's a context kind of issue here on whether it's a series or a sequence. So be really, really careful with that. Right, that's arithmetic. Everybody okay with that? Cool. Right, then we have geometric series. Same thing. Going to be the sum of the terms in a geometric sequence. So this time the numbers are going to be increasing by a multiple instead of something that you're adding. This is your formula. Again, there are a couple on the formula sheet, but this is the one you really want to worry about. So what are the things I need to know? I need to know n, a sub 1, and r. Okay, so we're just going to look for those the same way that we did before. Hunter, shut up, please. We're going to look for them in the question here the same way we did before and just plug them in. So I'm trying, in the first question, I'm finding the sum of the first 10 terms of the geometric series with a sub 1 is 6 and r is 1.5. Okay, so that's 10. Okay, so 6 is a sub 1. Then parentheses 1 minus 1.5 raised to the 10 divided by, let's see,
1 minus
notice this is the only formula that doesn't have n minus 1. It's just n. Now, hold on. Don't type it into your calculator yet. The way that you have to do this is very important. It is going to be very difficult to try to put this in the calculator all at once. So I want you guys to break it down into steps because it can really mess up your answer if you type it in incorrectly. So the first thing you guys want to do is type in just what's in parentheses. Just that part. Type that in first. So I want you to type in 1 minus 1.5 raised to the 10. Just figure out what that is. Okay? Whatever that is, you're just going to write it down in the parentheses and the next thing that you're going to write down. And you can round. You can round. Alright, so do that first. Just put that one part in your calculator and put it back in the parentheses. The second thing I want you guys to do is figure out what the denominator would be. What the denominator would be. What's 1 minus 1.5? Good. Great. Now you guys can put that in your calculator. You can do 6 times this divided by negative 0.5. $680.4. Okay, so because this formula is a little bit more messy, you need to break it down into pieces before you try to stick it all in your calculator to make it a lot easier for you. Okay? This next one, find S sub 8 for the geometric series 2 minus 4 plus 8 minus 16 plus dot 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 dot. Okay? What do I know? Do I know what A sub 1 is? It's 2. 1. Okay. Do not turn that into a plus, by the way. I'll explain why in a second. So you have 1 minus, and then clearly you guys can see I'm multiplying times negative 2 for the numbers to change, right? That's why r is negative 2. And then the exponent is going to be 8. And then I have 1 minus negative 2. Now it's very important you guys keep the parentheses there when your r is negative. Here's why. Isn't the negative 2 being raised to the 8th power? It's not positive 2 being raised to the 8th power, right? So it's like an order of operations thing. When you guys have a minus and then the next thing is negative but it's being taken to a power, you can't turn that to a plus. Right? It's a delicate order of operations kind of situation here. Alright, so as you're working through this question, again, you guys need to make sure that you're using your parentheses first so you guys don't get confused in the calculator. Alright, so go ahead and do that part for me first. Make sure you have the parentheses all set up. Very careful, everybody should be practicing. Just do that one part so we can make sure we're on the same page. Alright, what do you guys get just for the parentheses part?
Negative 255.
Okay, very good. Did everybody get negative 255? We need help anybody out with their calculator? Alright, so remember how I was just saying up here that we can't make it a plus because the negative 2 has the exponent? Can I turn this to a plus? Can I make this 1 plus 2? Yeah, that power that we had up here is not applying to this situation down here. So I can turn that into a 1 plus 2, which is 3. Thank you. Alright, then you guys can just put that in your calculator and figure out the rest of your answer there. Tiffany, do you already have it? Okay. You got what now?
Negative 1.
Is that what you got, Tiffany? Okay. Negative 170. Did anybody not get that? A little bit more explanation. Cool. Alright, I want to see if you guys can give the next one a shot on your own. Remember, we still have that a sub n formula in our back pocket if we need it. So I want you guys to see if you can figure out how to approach this one using the same formula we were just working with. But also keep in the back of your mind that we have a sub n. Be very careful as you guys are entering it into the calculator. Alright, what did you guys get? Negative 3 is what you should have gotten. Alright, so what does this 11 have to do with anything? That's the n. Remember for S sub n, n tells you how many terms you're supposed to be adding up. So look for that number. It serves the same purpose as it did for the a sub n formula. It tells you how far you're going out in the sequence. So S sub 11, you already have your first term. 1 minus negative 1 in parentheses raised to the 11. Oops, sorry, that's parentheses. That's what it should have looked like initially. And then you guys are supposed to do the top part here very carefully in the parentheses. I believe if you type that in, you just get 2. So it simplifies everything down a whole lot. And you do just this parenthetical expression here, you get a 2. And then down here, you get a 2. Okay, so it simplifies a lot in the next step, and then when you plug that in, or if you cancel out the 2's, you notice you'll just get negative 3. Alright, so again, it takes practice to make sure you know how to enter that in correctly and carefully. So make sure you're really, really careful during that particular step in the process. Alright, when you guys do the same thing, well, I'll let you guys start it, and then if you get stuck, I may have to help you guys out. Maybe, I don't know. Maybe, no, that's not what I wanted. Come back. Push the button. Where's the button? Alright, so go ahead and give it a shot. If you guys need help, I'll come back around and help you. Remember, this is geometric. Actually, hold on, that's a good point. Pause for just 1 second. This is the section of the notes for talking about geometric, but you guys see how the directions don't say geometric for the question? That's going to happen again, just like it did on day 1. It's not going to tell you what kind of series it is. You have to analyze the numbers, figure it out. And this is the most common mistake. Everybody stop for a second. Because this is the most common mistake that people will make. Because they see a bunch of pluses, they automatically think it's arithmetic. Right? But that's not going to tell you whether it's arithmetic or not. A series is always adding. A series is just taking the sequence and adding them together. So that doesn't define what kind of series it is. It's the numbers themselves that define what kind of series it is. So look at the numbers, and you have to analyze what the pattern is. How do you go from 0.2 to 1? And then how do you go from 1 to 5? Multiply times 5. So you guys see how we're multiplying to advance through the sequence, even though we have physically written pluses? Don't let that confuse you. Just because you see addition each time doesn't mean that it's arithmetic. You have to look at the pattern. Okay? This one is geometric, so make sure you're using the geometric formulas. Okay, go ahead and keep going. So, but remember, I was just saying it's geometric. This is the divided by 5. But this is the arithmetic. Oh, formula. You know what I said on this? Nope. Just write it out. And you do know R, right? So to figure out what that is, you can divide backwards. If you do 1 divided by 0.2 or 5 divided by 1, you get 5. You should have 5 raised to the n, because n is what we have now. That's because I know, so base of 1 is 1. So that means you're supposed to divide nope, so go ahead and change this to that number. And then now you still have 5 raised to the n. Do you remember what you're supposed to do when you have the exponent and the variable on the exponent?
No funny business.
Yeah.
Are you? How is
Really long.
Oh my god.
You guys should be noticing something from last lesson that you have heard last unit. You're doing the variables.
Got it.
How do you get the variable as the exponent?
Because you can't do anything because it has a.
Right, so you can't leave it like this, so how would you get it into? What do you call this kind of function? Oh, okay. Alright, many of you guys have probably run into some sort of roadblock at this point. potentially. Okay, what do we not know about this? The n. So we're going to have to find it, and like we were just discussing, this is a geometric series, right? So we have to use what formula to find n? What other formula do we know? We know the a sub n formula. If you guys are missing something, just like before, if you're missing something, go use your a sub n formula to find it. Do I know what a sub n is?
No.
It's 65. What comes next? A sub 1. What's r?
5.
It's 5. You're multiplying times 5 each time. N minus 1. We've done this last class when we were trying to solve for n. What do I do first? Divide by 0.2. Get 5 raised to the n minus 1. What do you guys remember about these? What are these called? These are exponential functions. How are you supposed to solve? Turn into a log. So it should be log what? Log base 5 of 3125 equals n minus 1. So you guys should know how to evaluate this. Remember the division trick thingy? And then you add 1.
Wow. I added 1 from this.
Well, add 1 to what? You don't know what this is.
Isn't it like 2, 1, 8, 5,
It should be a whole number. Log of 3,125 divided by log of 5 is 5.
Oh, I didn't divide.
So n is going to be 6. Yeah, so make sure you guys know that if you're missing something, you have to go to your a sub n formula, and you could be missing any one of those pieces, a sub 1, n, or a sub n itself. Then you start plugging stuff in. What comes first? 0.2, 1 minus 5 raised to the 6 over 1 minus 5. Carefully plug that into your calculator with the parenthetical expression first. Wait, what is that? Oh, that's huge.
That's a big
15. 781.2. The last page is calculator only, so alright, did everybody get 781.2?
Yeah.
That's kind of the pinnacle of difficulty for these, is when you have to find n for a geometric. But again, like I was introducing for this example, they may not tell you, they may not tell you what kind of sequence it is, or series. So you have to look at the numbers to figure out whether it's arithmetic or geometric, and don't let the fact that there are pluses there trick you into thinking it's arithmetic each time. So you have to look at the pattern between the numbers. Alright, what we're going to do over here is calculator only. There is a way to do it by hand, but I'm not going to make you do it by hand, so I'm going to teach you how to do it with the calculator. So this is called a sigma. We learned the lowercase sigma before. Looked like that. We did that for the standard deviation. This E thing is uppercase sigma, and it stands for summation, so they call this summation notation. And so, summation notation. We have 3 different ways you guys can have the notation represented. If you guys see A times X, or just something that has addition like this, where it looks like A, MX plus B, like that, that's going to be arithmetic. If you guys see something like this, where you have it raised to a power, like an R, and then you have the n minus 1 or whatever, that's geometric. If you guys have anything else, it's called an other. It doesn't have a specific name. No, I'm just saying they're presented different ways. So we're going to be using our calculator. It doesn't matter which way it's presented. We're going to be using our calculator the same way each time. Okay? So you guys do need to know how to use your calculator. I've written out like what buttons to push, but this is what it should look like in your calculator. So we're going to start with this one right here. So what I want you guys to do is hit second step. Second step. And then there should be options along the top. You want to go over to math. And then option 5. and you should see this pop up on your screen. Do you guys see sum? So we're telling our calculator we want to take the summation of something, right? Now we have to tell it what it is we want to take the summation of. So now what we're going to do is hit second stat again. Second stat. But instead of going to math, you're going to go to operations.
Wait.
Ops.
Do you click enter?
No, don't hit enter. Don't hit enter. We're just building what we want it to do.
Second stat.
Second stat, and then you go to ops 5.
Wow, I got like some ops. I got that. Oh my god. Like I pressed alt 5 and I got that.
Okay, so you're going to sit here. For the 84s, you're going to stay in the screen. It has a bunch of stuff that you're going to fill in. Everybody else, you'll hit enter and it has a sequence come up. Right? No. It just means that you're going to enter it in that screen. They're going to enter it in this screen. Alright, so listen up. Now that you guys are here, whether you have an 83 or the other fancy ones, the next thing you're going to do is write down what the expression is. So you guys are going to type in x minus 1. Because that's what the question wants us to take the summation of, x minus 1. Okay? Then for everybody on an 83 or the lesser 84s, you're going to hit comma. Comma is, I don't know, where's comma? Comma is above 7. And then x, and then another comma. Hold on, I know yours.
You didn't tell us. Oh wait, is this for us too? Okay,
Yeah, for the 83s. So we're just following this rule. You're going to type down the function, comma, x, comma. You have to tell it what variable it wants to be working in. And then your lower bound and upper bound are these numbers here. See how you have two numbers on the edge of the sigma? You would write your lower bound is 1, another comma, then 12 is your upper bound, close parentheses, and push enter. And then you should get a number.
I got 66.
So you need to write the expression of x minus 1. And then here you're going to tell it the variable is x. Go down, you're starting at 1. Down, you're ending at 12.
Are you kidding me?
So down your stuff is 1.
Are you sure?
Or, no,
This one plus unit. Plus 3.
It is plus 7 today.
7.
Are you kidding me?
You guys should have 66 pop up on your screen.
It's kind of complicated.
That's the answer.
So after we write the x minus 1, we're gonna write, we have to write comma and write our lower and upper bound.
Alright, so one more time, listen. You hit second stat, math 5, second stat, ops 5. That gets it all set up. You should have sum and then sequence. Then you tell it what the function is, what the variable is, and what your lower and upper bounds are, and push enter. It does all of the formula work for you. You just have to give it the information it needs, and it'll give you the number. Okay? Doesn't matter whether it's arithmetic, geometric, or others. It'll do the work for you. Okay? Let's try this one. Alright, so everybody hit second stat. Second stat, and then go over to math 5. So you get the sum set up. Then you go to second stat ops 5 to get the sequence set up. Now, what should you enter in for the function? 3x squared. I'm just going to type that in. That's your function. Then you have comma x, comma. You have to tell it what the variable is. Oh, the comma is above the 7. And then what's my lower bound? 2. What's my upper bound? 5. Enter. 162.
Oh, I got it.
No, I don't know how to do
162.
And I should put 1 for always. Do you like to put 1
For the set. Yep.
You get the different variables.
Yeah. We're just turning all the variables to x. Right? This one. Second stat math 5. And second stat ops 5. Sequence. Now for this one, you don't need the parentheses around the 3. It's actually more important that you guys put the parentheses around the, well, your x, sorry.
Oh.
3.
Where'd you get that?
Oh.
Here.
What if they didn't put the
Right. What is it?
Just scroll back.
Do you when we plug it in, do we have to put ours like the break the parentheses?
No.
Or just put create
It's
a barrel?
correct. It's only important that you guys have the exponent in parentheses if there's more than one thing in the. How do you get what? No, just treat it as x.
Okay.
If they give you a different variable, just swap out x for that. So again, have your exponent in parentheses.
Start with 2.
It does start with 2, and it ends with 6.
I don't remember what you typed in the order. 121.
121. 121. It is a process, and you guys do need to remember it. Alright? Try this one on your own. See if you can get the right number. Try that one on your own, see if you can get the right number.
Do we put the carrot or not?
So what?
Do we put the carrot?
There's no powers here. They split it up. Your expression like for this one would be 5x minus 3. You go down, I've already said that.
Oh.
Start at.
I got that.
And then end at 3, and then step to 1. And so you basically what you're doing is you're telling it what yeah, so when you put it all in the one spot, you're asking it to get all the numbers individually. That's because you close the parentheses, you're not supposed to do that. You're not supposed to close the parentheses. So when you write the expression, you just write it and go straight into the column.
That's it.
You guys should have gotten 510. You've gotten 510.
So do we only close it, like, what is it?
You only close the parentheses if you have to insert a separate set of parentheses for an exponent. Alright, the next one I want to just to save time, go ahead. My god, I hate you. I'm going to skip this one and go over to this one. Alright, so we're going to do this one together, so you guys go ahead and do the sum sequence thing. I'll talk about how to enter this one. So set it up so you have the sum sequence thing. Now there are 2 ways to do this. You guys can, well first of all you have to write this, obviously, but how you do the 2n part, there are 2 different ways you can do it. You can actually use the multiplication symbol, like the x, and then write 2 raised to the n, or you could leave it in parentheses if you wanted to. But if you're going to include parentheses around the 2, you need to close that set of parentheses before you keep going. Or you could just do 0.5 times 2 raised to the n without the parentheses. It'll get the same result.
I got negative 1,000.
That's where you should go. Alright, so just be really cognizant of how you're putting stuff into the calculator and you should do it. Just remember the steps in your calculator and you should have no trouble with those. Alright, really quickly our last topic here, really quick formula. You can't use the calculator for this one because these are infinite. So these are infinite series, this means that they don't stop. But interestingly, you can still add all the numbers together and get a result. I don't have enough time to explain why, but this is one of the cool things about math. If something keeps going on forever, you can still add those infinite amount of numbers and get a concrete answer. But only if your ratio is between -1 and 1. So this only works for geometric, right? Infinite arithmetic series diverge. You actually can't find a specific answer, it just goes to infinity. But for a geometric, if your ratio is between -1 and 1, so it's a smaller number there, like a smaller fraction, then you can actually find a concrete number. So I'm going to do this really, really quickly for you guys.
Could you please send 9th and 10th grade students who are currently enrolled in at least one AP class this year, as well as any juniors or seniors and AP pre-registration in the cafeteria at this time? Thank you.
Is that anybody in here? Just watch the video if you guys have to miss this. But really quickly, the way you guys approach this question is use this formula right here, which is on your formula sheet. You don't have to memorize it again, no memorization. All you need is two things. You need to know what the first term is and what the rate or the ratio is. So they haven't written it out for us as a sequence, but you guys can still find the first term. What do you think you would do to find the first term? We are going to be using the equation, but how would you do that? No. Well, why?
Because it's the first number.
It's not just because this is the first number. In order to find the first term, you take this number and plug it in.
Oh.
Remember how this is where we start?
What do you get?
Remember that's where we start? Since we're starting here, this is like the a sub 1 thing. So if you plug that in for n, you get 2 times 0.4 raised to the 0, which does equal 2. So if you guys are, it doesn't always equal 2, right? Or that number. So if you guys are looking for a sub 1 for the formula and they don't provide it for you, if you just plug in the bottom number, that's a sub 1. So our formula is going to be 2 divided by 1 minus what? What do you think r is? 0.4. The r is always the number that's inside the parentheses there. Alright, so you guys are looking for the rate. You just look inside the parentheses and there it is. So you just put this in the calculator. Make sure you guys put that in parentheses or find that first. It should be, that's 3.3 repeating.
I did 2 divided by
Did you put parentheses?
Yeah. 1 minus 2.
Where'd you get 1 from?
The formula. It's on your formula sheet.
Oh, I got it, never mind.
Okay? Really quickly, what about this one?
No, what? No, I got it. Yeah. 0 minus 1.
Hold on. What's the ratio? What's the ratio?
0.
What's the ratio?
I don't have 0, so plug in.
Negative 1. No. The ratio is inside the parentheses, right? You can only use this formula if the ratio is between -1 and +1. This ratio is too big. So there would be no solution.
Oh, yay.
So if your ratio is too big, if it's bigger than 1 or less than -1, it's just no solution. You just say you can't do it. Alright, so we're going to wrap up with one of these last ones. Which one do you guys want to do?
Number 2.
The one on the right? This
Actually,
one?
the second one's always easier. First one.
Okay. Alright, so how do I know that this is infinite, by the way?
Because we keep on going.
It says ... Keeps going. Alright, so I need to know a sub 1.
2.
2. I need to know what the rate is. What am I multiplying each time? Because it has to be geometric. What am I multiplying each time? If you don't know, divide backwards.
-0.1.
-0.1. And because it's subtraction, make sure you remember to write the double negative there. You can change it to a plus in a second, but it is a double negative. So it should be 2 divided by 1.1.
1.81. 1.82.
The 8-1 repeat, so you can just write 8-1 repeating. Alright, so that's a miniature formula. If you guys see you have infinite geometric series, so that's what you would use. Alright. Of course. Why wouldn't it be?
What? Maybe rushed it. I know, we rushed it.
It's not a class.